Hello YouTube, this is my milling machine. Yeah, you should know about it because I have shown every internal part of it, I think. Anyways, I was just going to do a quick project here, so I have an instrument panel for my sawmill, and it is pretty neat here. It's a display with a touch panel, and I just press there and the sawmill will raise the blade 1 board thickness. It's pretty neat, but of course it is still experimentation stage and doesn't work too well, so I was going to add a section here with the manual button so I can override this and do it manually. So I have a milling sheet here, and I just started up the milling machine, and I got some squeaking from the Z-axis here, or C-axis. I will say Z-axis. Yeah. There you go. Sounds horrible, right? Yeah, and it tries to adjust the position there. It's not happy with it. There is a lot of backlash or drag or whatever. The servo motor is pretty strong there, so it can overcome a lot of the resistance there. So what do we have to play around with? So this machine has linear rails, so it is upgraded with that, and that works really well. It has a gas spring here to offload the weight, or to offset the weight of the spindle head. And here there is a ball screw and a nut, of course. That is an axial bearing. We have the servo motor. And yeah, you don't have that. You only have 2D hearing, but I have 3D hearing here, so I have diagnosed it to up here somewhere. Here, here, here. And actually everything points to that it is up here. It is the brake unit that doesn't release, and I don't understand why. So that is what I need to fix. I have said it before and I say it again. If you don't have an updated electric schema for your installation, you are blind. Here is how the brake is operated. There is a SIG out to a relay. So when the servo drive is enabled, it should trigger that relay. That will give 24 volt up to that brake there. That is an electromagnet there. And that's a flywheel diode. So let's see if I enable the servo, what happens. So I have 3 auxiliary relays. The innermost there, that is for the brake. And I enable it. So the relay thinks it is operated. LED kind of clicks there. And the LED lights there. Let's see what happens with the voltage though. Yes, I dropped it. I need more arms, I tell you. But I measured in here, and there is not full voltage in there, out there. So it seems it should be 24 volt. But there isn't 10 volt or something like that. So there is something on the way between here and the relay then. Yeah, I am in that mood where I want to do the least possible just to fix it. I don't want to work with it, I want to do that instrument panel there. Anyway, I measured the continuity between here, and the cable is fine. So I will need to take down the servo motor and see if I can figure out what is wrong with it, or the brake. Yeah, you know, there is a bracket there, and I will just unscrew it and take it off. Yeah, that went really fine, no problem at all. There it says polarity, so I have used the Google Translate, and it says 1 is positive and 2 is negative, and DC 24 volt, of course. The problem was to translate it back to Chinese though. Anyways, so I have this connector here. I only have that specific one I got with it. Maybe I can do some tests here anyway. I'll go and get a power supply and apply that manually. Yeah, and this is one of those critical tests here. So what happens now that determines the rest of this video. So You know, that was a relief. This is how it should sound like. So it is, after all, the brake is fine. It is the power or the voltage to here that is the problem. It was actually really a relief there. See, one of my pre-tests here, I thought I didn't have so much voltage here, so maybe there isn't anyway. I have to check all the wiring now. So I'll try here in this end, and you have to activate your 3D hearing. That was a pass. So that cable is alright. Yeah, that kind of puzzles me until I follow the cable, the ground cable. It is that one. This is my manual operated brake switch I had at one point in time, and it fell down there because of reasons. That doesn't fit in a precision video. I'm sure if I put that to ground, everything will come together. Okay, Linux freshly started. Activate 3D listening. There we have it. It works. Haha. That's how it should sound like. Now it will work. Yeah, 7 motor back up there, over, up there. So I will show the homing of the Z-axis. You heard that? But I won't make that sound again. Stop. Yeah. There it is. It works. Ha. Yeah, so this was kind of a disappointment, wasn't it? We all hoped for that I had to open up the servo motor, replace and repair that brake unit there, put it together and all that. But no, it is already done, and it is only a few minutes into this video. I guess I have to show you the milling out of the new instrument panel. So this one is the old one, but yeah. So I didn't plan to make a video of this. Yeah, I know it's hard to believe, but everything I do isn't so interesting. I was kind of just looking forward to a peaceful evening here, to milling out here with a lot of slotting in aluminium with a great potential for clogging up the mill. But I think I'll do that tomorrow though. You won't notice that it is tomorrow, but I will tell you that it is tomorrow. The 3mm aluminium sheet clamped to the table. It isn't so critical. I will use my high-speed spindle and a 3mm end mill. So one flute end mill. So yeah, but it is of that type, you know, when you want to mill aluminium in one of those gantry mills, 30-40, 40-30, 60-40 or what they are called. Then you have to be careful. I think it will work. I hope it will work. We will see if it works. Because if it doesn't, then well, I hope we will not come there. So I do have some cutting fluid. And I also have some air assist. But I will start dry. That is the best. So this is mostly an exercise in clamping the workpiece. I will start by milling out the contours. And then a number of holes and so the complication is that my normal spindle is kind of in the way here. You will see that as soon as we start milling, and we do that now, and we put on some music so you can enjoy this. And there it is ready. Went fine actually, but I think I was pretty lucky to get away with that end mill there. You see how the chips, how they stack up here. Firmly fused together. But it worked as I said, so nearly a catastrophe is no catastrophe. Now I have to deburr it. There are quite a bit of burrs on it, and I need to make 2 breaks on it. So it looks alright and feels alright sitting out there. But here it is. Yeah, no, I think this will be fine. This will be fine, beautiful. And that's all for this video. What? You want to see it being put together? Well, alright, I can show that, but I will not show the deburring of this part because that is my zen time. I enjoy doing that. And after a fair bit of soldering, here's what it looks like. It looks actually quite nice there. So what is new is this section here. It's a manual section. Up, down, fast, slow. In this position 12 volts goes directly to the motor. In this position it goes via a PWM regulator, so I can adjust the speed. Here is a switch to go from switch between the manual mode or via the controller, and we are not covering the controller today, at least not now. So let's try to see if the manual section works. That is what I wanna see. Is this part here. Yeah, it's a fair bit of soldering. It's not so easy with those stiff cables there. I tried to solder directly on those, what they now are called, but it didn't work, so I have to do it in this way. There, and motor connect. It may go up, or it may go down when it should go up and all that, but that I easily fix. So where do I want to start? There, we try master switch. Let's see if it burns or not. No, it didn't burn. It didn't burn. Will it go up? It does go up! Haha! Well, then it works, I think. Oh, great. Yep, fantastic. I always have some soldering issues there, but not this time, obviously. So, see if I can connect up the controller and some more soldering. And here is the microprocessor ESP32 Arduino framework. Yeah, you know the drill there. Bit of soldering. I try to reduce the length of the cables here to make it neat, but yeah, it is difficult. But it looks pretty okay now. 3.5 volt, it doesn't say 3.3 volt because that goes to the DRO. Yeah, you will see it later. So I can keep that on even if I want to reboot the controller, which I do with a 5 volt. And this is for water, that is for that little solenoid valve there. And here you have the controller from the DRO. So let's start hooking that up. So I'm eavesdropping. I'm listening to that signal. I don't do anything with it. I just listen to it. And I have had a little bit of, I heard a lot of disturbance problems or interference problem when the motor is running, not when it is idle. That is all right then. So what did I do with the screws? They are there. And now you don't see that. We do this. Yes, I have this display and there are two of those batteries there. I will replace them and take the power from here instead. That's the purpose of that 3 volt there. So now they are out. Let's see if we can get something going here. Then this one should go in there. Power on, 12 volt and 3 volt. Oh, that didn't work. Oh. Start by putting in the 12 volt supply voltage there. There we go. Then 12 volt, 3 volt, no 5 volt. Oh, why didn't it work? I was thinking. And it doesn't work. No, it does work. Ooh. But I think that indicates low voltage, low. That can be, and I know why. So what drives this? That is a 3.3 volt buck converter, and I had to put a diode after that. So this is 2.85 volts. I could be right then. I think maybe it is right. There we have it. So now that yeah, so that is a kind of the problem I'm troubleshooting here. But you see that. So I have a signal there and I have a signal there. So now the idea is that I can say that I want to go up. Yeah, this is a very exotic language here, and there are actually people that understands what this means. I'm one of those few selected ones. Up means go up 27 millimeters. So this is basically a servo system, and the motor is not controlled, but this one is, and that didn't work at all. I have some settings here. Ah, yeah. Yeah, so this is a new controller, so that is, I don't have the feedback, any feedback is set here. So, but let's say a K factor here of 3. Yeah, this isn't so funny if you are looking for it, I guess. So let's see if we can go up 27 now. And let's have that part, all parts included here. Something like that, perhaps. Reset position. Should go up to 93. Yeah, K factor is too strong there, but it will. I'm pretty sure it will stop now, close to 93. Yeah, that's not bad, eh? So it is basically a servo system. This DRO is my encoder, And the motor up here is just a DC motor. It's nothing special at all. It is just a DC motor that is driven by 12 volt. Plus 12 volt it goes one direction, minus 12 volt it goes the other direction. But I mean, it does work pretty well to run it manually, in manual mode, but yeah, you know, I have to sit and try to step up closer and closer to the set point where I want to be. This is intended to skip that, so I don't have to do that. Yeah, so 1/10 of a little bit over 1/10 of a millimeter off there. I mean, that is perfectly fine when the milling lumber. So the idea is that I should be able now to reboot the controller, update the software, for example, and then come back here. That didn't work. Yeah, there it comes. There it comes. Yeah, that's what I'm troubleshooting, but I mean, it's a hobby project, so anyways, I think you have seen it. I will have to put that one up there with some adhesives. Yeah, I think this is as exciting as it will be in this video. We started with a squeaking Z-axis and ended up here. Thanks for joining me, and have a good day, week, whatever. Have a good everything. Thanks for watching.